La bienvenida, los amigos. How you doing? Yogi here again. This is the fourth video in a series of 7 looking at ratios. In my last video, I went through some examples of writing a ratio as a unit ratio, where the second number in a pair was 1, and using a scale factor to work out the size of one amount given the size of another amount. Difficult stuff to get a brain around. In today's video, we're now going to look at how a regular ratio can be used to do something similar. Since regular ratios don't involve scale factors, I'm going to focus on the algebraic method I used in the last video. If necessary, go back and have a look to refresh your memory about the algebraic method because it's fairly important. Okay, in this unlikely example, let's consider a painter who wants to make the color purple to paint her friend's house. To make purple, the painter will need to mix blue paint with purple paint in the ratio 3:2. If the painter has 24 cans of blue paint already, how much purple paint will she need to buy? One way to work out the answer is to list multiples of given ratio, equivalent ratios, until 24 appears on the blue paint side on the ratio. A more efficient way would be to use algebra. Let's look at both methods. In the multiples method, we know that the blue to purple ratio is 3:2. If we simply started with thinking about getting 3 cans of blue paint, then we would need 2 cans of purple paint. If we then double this, we would need 6 cans of blue paint and 4 cans of purple paint. If we continue looking at the multiples of 3, so 3, 6, 9, 12, 15, 18, 21, and 24, until we get to 24 cans of blue paint, which is what we know the painter already has, we'll find that she needs 16 cans of purple paint. This method is fairly simple and straightforward. However, depending on the numbers involved, could take quite a long time to finish. In most cases, a much better solution would be to use the algebraic method. Again, as we've seen in past videos, we start by writing 2 equivalent ratios. The ratio of actual cans of blue paint that will be needed to be used to actual cans of purple paint is equivalent to the given ratio of 3:2. We can write this as an equation. However, we know something about the blue paint. We know that the painter has 24 cans of blue paint already. What we don't know is how much purple paint is required. As before, if we don't know a number in algebra, we give it a symbol. In this case, let's call it P, where P represents the purple paint that needs to be bought in order to paint the house. If we substitute these two values, 24 and P, into the equation, we will find that we have 24 is to P equals 3:2. Now, we don't like to have algebraic pronumerals on the bottom of a fraction. So again, one of the tricks that we can use is to flip everything. If we flip the ratio 24 is to P, we will get P divided by 24. And we know that if we flip one side, then we have to flip the other side. If we flip the original ratio 3:2, we'll now come up with the ratio 2/3, or 2:3. To get the P by itself, we need to multiply both sides of the equation by 24. This gives us P by itself on the left, which is what we want. And on the right-hand side, we have 24 times 2/3, which equals 16, which is the same answer as we got previously using the multiples method. Therefore, the painter needs 16 cans of purple paint. Using the multiple method is not always possible. Take the next question, for example. Pause the video for a moment and try to work out the answer with what you know about ratios already. In this question, as before, we're given a ratio, one amount, and asked to find another amount, in this case a height. Start by writing 2 equivalent ratios. The ratio of Grace's actual height to Caitlin's height will be equivalent to the given ratio of 9:10. Now, we don't know Grace's height, so let's give it a symbol, in this case maybe h. Caitlin's height, however, is known. It's 152 centimeters. Once again, as we did in the previous example, if we substitute the h for Grace's height and replace the words Caitlin's height with the number 152, we have an equation now where we have h divided by 152 equals 9/10. We can get the h by itself by multiplying both sides by 152, and if we do this, h will equal 136.8 centimeters. Therefore, Grace's height to the nearest centimeter is 137 centimeters. The algebraic method of using a ratio and one known value to find another known value should be starting to make a bit of sense now. In this video, we've used that method, and it's the same method we used in the previous video on unit ratios. The only difference is the ratios in this video are not unit ratios. In the next video, RAT005, I'll investigate the use of scale ratios for use in maps and diagrams. Until then, adios.